Hey guys, so this is a crash course review on reading the periodic table of elements. A couple of assignments above this fun sheet was one that just said periodic tables, and if you opened that, there was a copy of this color-coded periodic table, and then there was a blank black and white one. If you have a printer and you want to color your own, then print the blank black and white one and color it to match the example that's in there already colored, and make sure you match the key coloring up top as well, because that's important when we start talking about the different family names. So if not, you can just open those on your computer and leave it up on your computer screen, and you can work from that to refer to the different things we're going to talk about. Or you can draw one, whatever you want to do to have a copy for yourself. They are readily available on the internet. The colors might not be the same as what we have colored, but everything else would be the same. So just do what works best for you. So we're going to review this table and talk about a couple of terms from your last fun sheet. On this page, I wanted to review with you the periods, and the periods are the rows that go down like this. There's 7 of them. They go across from left to right, and they go just like I went on that arrow right there, from left to right. And think of it like a sentence. You read from left to right, and you put a period at the end. So the second row goes from left to right, and you put a period at the end. All the way down the table, all 7 rows. These 2 rows right here actually go in right here. So, well, right here. So they are not rows 8 and 9, or periods 8 and 9. Those are actually periods 6 and 7. So just remember that. Look at the atomic numbers, and you can see that this is 58 right here, and there's 57, so it gets inserted right here. And same thing with this one's 90, and that's 89, so it gets inserted right there. And then that shifts the whole table to the right. So there are only 7 periods on the periodic table. Same thing all the way left to right, period at the end. So those are your periods, and periods tell us how many energy levels there are in a atom. And so I need to write that right here for you. Hang on. Equals energy levels. And if you remember, when you drew your atom, the energy levels are the rings around the nucleus of the atom. All right, moving on. So next we're going to talk about the families, or the groups, and those are columns. And in that fun sheet that you did, I told you that columns go up and down, like a column holds up a building, and so that's up and down. And so these are numbered 1 through 18, all the way across. And they just go up and down. And these are called families because the elements that are in the family have similar properties, and they're grouped together for that reason. And the number across the top also tells us how many electrons are on the outermost ring or shell of the atom, and we're going to talk about that in a second too. Alright, so this tells how many electrons are on the outer shell. That's what we were just talking about, the families and the groups. And so, I'm going to go back to this one. This one right here has 1 ring in the outer shell. Not 1 ring. Well, this one does, but this has 1 ring, and then this has 1 electron in the outer shell. This one has 2 rings and has 1 electron in the outer shell. So from looking from knowing its period and its family, you can tell two things about the model or that atomic model of it for that element. So this is family or group 2, and that means it has 2 electrons on its outermost shell. So if we took this one right here, which is calcium, we would know it has 2 electrons on the outermost shell, and it was in 1, 2, 3, the 4th period. So we would know that there are 4 rings, and then that there are 2 electrons on that last ring. And on our next video, we're going to do that together, and so that'll make more sense to you then. Alright, so I'm going to keep going. I just wanted to make sure you knew the difference between the periods and the families. Oh, I do need to tell you this. So 1 and 2 were easy, but our rings only have, the innermost ring can only have 2 electrons, and then it's 8, 8, and then 16, and 32. So these numbers can't be on the outer ring, and so what we do is a little bit of math. There's always exceptions in science, and this is an exception. Those transition metals that are yellow, we can't use their numbers 3 through 12 to figure out what number is on their outermost ring. So we just kind of skip those ones, and you'll learn about those later in chemistry in high school, but for us, we don't talk about them. And so, but 13 can't be a number on the outermost ring, so we just subtracted 10 from all of these, and so it would be 3. So, oh, actually, I went the other way first. Sorry, my bad. 18 minus 10 would be 8. So this row, my bad. This, I don't want to use the word row. This family has 8 electrons on its outermost energy level. This column or family goes up and down, remember, has 14 is the number there, but we subtract 10, so there are 4 electrons on the outermost shell. So really you're just using the tens place, I guess, digit, or the ones place digit. That's the ones place digit. That's why I don't teach math, guys. The ones place digit to tell you how many electrons are on the outermost shell. And again, this will make much more sense when you see the next video. Okay, and then you did this in the other video too, but I want to go over it with you again. So the top number is your atomic number, and sometimes it's in the center above the letter, and sometimes it's in the left-hand corner. It's still the atomic number in either location. Then you have the element symbol, and then you have the element's name, and then you have the atomic mass. And then all of that information can tell you everything about that specific element and its atom makeup. And so you need to remember that the atomic number, which, remember this is our atomic number, is how many protons there are. That's the same number. So if the number 6 for your atomic number, then there are 6 protons. The next thing to know is that the number of protons equals the number of electrons. So for the atom of carbon, if there are 6 protons, then that means there's 6 electrons. They're the same number. They equal each other. And then we talk about atomic mass. So the atomic mass is the protons plus the neutrons. But we don't know how many neutrons we have. And you will see as we start dissecting the periodic table that sometimes it's not an easy number like 12, and you subtract 6 from 12 and you get 6. So the numbers are the same. That's not always the case. Sometimes you're going to have some really crazy numbers, and there's going to be a whole lot more neutrons to keep the nucleus stable than there are protons. But in this instance, it's going to be the same. But to find how many neutrons there are, you take the atomic mass and you subtract the number of protons, and that gives you the number of neutrons, which in this case is 6. We'll get to that together. So next thing we're going to talk about then, what I just told you. The neutron number is not always the same as the proton number. That's really, really, really important. Keep that in mind. All right, so in this assignment where you are watching this video, the next tab over has the next 2 worksheets that I have that I'm about to project for you. And here's a little bit of the directions. If you have a printer and you want to print the papers off and write on them, that's fine. You can write on them and then take a picture and upload it as a file to submit it for Canvas. Or if you want to write it down so you have the paper and then keep the paper, but then just type in your answers in the, click submit and in the text box, type your answers, that's fine. Just make sure that if you are not submitting this document, like you didn't take a picture and submit it, that if you're just typing in, your answers, that you keep the numbers the same. For number 1, there's a 1A and there's a B, and then there's a 2A and a 2B, and a 3A and a 3B. But somewhere, number 5 has a 5A, B, C, and D. So make sure you include all of the letter choices so that your answers match up to the right number, okay? So just make sure you number it correctly. All right, so there's these 2 papers on the next 2 tabs over. And the first one we're going to talk about is the world famous table. And that's the one I just put the number 1 on. And we're going to do the first couple together. So if you're just going to type the answer into the submit box on the text box in Canvas, then you can look at this video and pause it and split screen it and have my paper up. Or you can do that on your computer so the screen is bigger and download that file. Double click it, it'll download it, open it, and then split screen and have your answers next to it so you can see it on your computer. It might show easier. And I'm going to kind of jump around and go back and forth to the periodic table to show you some stuff. So it might be easier to have it on your computer so it's just stationary. All right, so number 1A is asking for the atomic number. And in this case, remember, the atomic number is in that top left-hand corner. So for hydrogen, the atomic number is 1. The next thing wants to know its atomic mass. And so for hydrogen, the atomic mass is 1. So your answer for 1A would be 1. Your answer for 1B would be 1. These are numbered going down, so the next one is below it. And it's asking for the element name. So in this case, the element name is magnesium. And then it wants its atomic number. So the order is changing every time, so make sure you're paying attention to what it's asking for. And if you need to, refer back up here to this information. So the atomic number is in the top left-hand corner. The answer for this one then is going to be 12. All right, so you're going to do that for 3 and 4, making sure you're answering the right question. Number 3 is asking for protons. Remember, the proton number equals the atomic number. So just make sure you're referring back up here to this little cheat sheet area to help you. All right, I'm going to skip ahead to number 5 and help you answer A, B, C, and D there, so you have an example of the different questions, and then we'll go on. So 5 wants the electrons. Remember that protons equal electrons, and remember that protons is the same number as the atomic number. So for this, it's going to be 79. All right, then that was the electrons. Electrons equals protons. So if there's 79 electrons, that means there's 79 protons. And remember that protons equals the same number as the atomic number. So what does that make the atomic number? 79. And what is the name of this element? It is gold. So there's just an example. And so like for that answer, you would have had 5A, 5B, 5C, 5D, and answer those questions. All right. Now we're going to go on to the question mark. And the question mark page, you need to use your periodic table to refer to answer these questions. So go back up a couple assignments and download the colored copy if you did not print and color one, okay? If you printed and color one, you can pull that out. If not, go back there, pull it up split screen so you can see. So number 1 here asks for a non-metal halogen family atomic mass of 35. So we're going to go to the periodic table, and it says a non-metal with atomic mass of 35. So I found number 35 because atomic mass is the number on the bottom, remember. And then a non-metal, so non-metal is the shade of blue that I'm in. And, oh, I circled halogen, and I meant to circle non-metal. I'm sorry. Non-metal should go there. So all of these blues are considered non-metals, and then we use that number 35 to 35.45 to get your answer. So your answer for number 1 on the question mark is going to be chlorine. Okay, number 2, 25 electrons, and it's a transition element. So go back to your periodic table, and your transition elements are all those elements that are yellow. And then it wanted number 25 for the atomic number. So this is manganese. Manganese and magnesium are not the same thing. I am not saying it wrong. It's manganese. There is a magnesium, but that's not this. So remember, your protons equals your electrons. And it said it wanted 25 electrons. And protons equals your atomic number. And that's how I found that one. All right, so then magnesium. So that's what you're going to do for the rest of those. So on this page, you just have to number it 1 through 20. You can submit all in one text box. So you would have 1 through 12. But of course it's like 1A, 1B, 2A, 2B, etc. all the way to 12A, 12B. And then page 2, make sure you separate them for us so we know, and do 1 through 20. If the question mark page is giving you a hard time, don't freak out about it. Don't worry about it. We can go over it together. We can even jump in on a Zoom call if you want to, and we can do one of those, okay? So take your time with this and email us if you have any questions. It's a lot, guys. I know it is, okay? This was a long video. But if we walk through it together, I think you'll still understand it. Hope you all are well. Miss you.